Hello, ladies and gentlemen, boys and girls. Welcome back to the 2000 Cayley paper. That's the grade 10 level contest. And we're on question number 5. So what does question 5 say? It's got a nice little picture. The first 4 triangular numbers, because they form triangles, are 1, 3, 6, and 10, as illustrated in the diagram. What is the 10th triangular number? Alright, so we need to stand back and think about the pattern. We have triangles. The first one is just a dot. The second one, there's 2 dots on each side. The third one, there's 3 dots on each side. So we're forming equilateral triangles out of dots. And so what we could do is just draw the triangle that has 10 dots on each side. It looks like this, and count the number of dots. That's an excellent way to do that. If you've done some math enrichment before in your life, you will probably be very familiar with triangular numbers, and you'll know that there's a formula for that. But rather than do either of those methods, and they're perfectly valid methods, if you did those, that's great. If you thought to do them, that's fantastic as well. I'm just going to do it, I would say, just by observation of layers, or noticing a pattern here. So the first triangular number, well, it's just a dot. So we get 1. The second triangular number is 1 dot over 2 dots. So 1, 2. We add those up, we get 3. The third triangular number, well, now we have 1 dot on top of 2, on top of 3 dots. Third triangular number, 3 dots for the base. That's 1, 2, 3. How about that fourth triangular number? 1 on top of 2, on top of 3, on top of 4 dots. 1, 2, 3, 4. And if we look, we get our calculator out, or we do it by hand, 1 plus 2 plus 3 plus 4, well, hey, that's 10. So the 10th triangular number is just going to be 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10. And we can just grab our calculator and compute that. 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10. Careful, try not to do it too quickly, or you might misclick, mishit a button, and it can be very disastrous for your calculation. But you'll get 55. And I'm not saying this is the best way to do it. By all means, there is a formula for this stuff. There are other ways you can do it. You can actually do a solution by picture, by drawing out the 10th triangular number and counting the dots. There's probably a couple other ways that I'm not thinking of right now. But however you choose to do it, really however you choose. They're not going to care what solution method you use. They just want the final answer. That's the beauty of the Pascal, Cayley, and Fermat. It's just final answer, multiple choice stuff all the way. So we see that 55 is A. We bubble it, we move on, however we chose to do the question. If this were the written question, we might have wanted to do the written contest. We might have wanted to develop a formula, but that's neither here nor there. If you're interested in the written contests, go take a look at some of the Galois videos, or just look at the Galois online on the University of Waterloo website. So that's question number 5, a neat little question with triangular numbers. They pop up. If you watch a lot of these contest videos, you'll see triangular numbers again, I assure you. So question number 5 got us feeling great. Bring on question number 6 in the very next video. Thank you guys so much for watching. I seriously mean that. Hopefully you'll join me for question number 6.